Next we are finding the moment of inertia of the circle we are finding. Okay. So in this see, we are finding the moment of inertia of the circle. In this, it is a circle. Okay. In this it has the radius of r. So the if you consider the total radius, this one, sorry, the total circle, this one, so you have the radius r. Okay. So in this you have to take a smallest element. This is the smallest element. Okay. So even though it is a smallest element, it utterly it looks like a considered a rectangle. Okay. You have to be considered this smallest element as rectangle. Okay. So from this smallest element, the radius from the smallest element to the center of the circle is small r. Okay. So the smaller element to the base of to this x-axis, it makes an angle of theta. Okay. So from one end to another end of the smaller element, it has the smaller angle d theta. Okay. So d theta is the smaller angle between from this end to this end. Okay. So and it has the smaller radius from here to here, that is dr. Okay. Dr is the width of the radial. Okay. Radial whatever the radial element is there, that is the width. Okay. So that is the width of the radial element. Okay. Now the width of the radial element has the distance of radius r from here to here. Okay. Now elemental area, so whatever the elemental area is there, so you know this is the width. Length you should know, no? Okay. So length is nothing but s is equal to r theta. Okay. So arc distance whatever it is there, so that arc length, this is the arc length from here to here, it is an arc length. So arc length is equal to s is equal to r theta, which you have studied in your PUC. Okay. So here theta will be replaced by d theta, so it will become r into d theta. Okay. So r into, it will become r into d theta. Okay. So this will be the arc length. So s is equal to r d theta, that is the length of this arc. Okay. Smaller element arc. So you know length is r d theta, width is dr. So you should consider this smaller element as the rectangle one. Okay. So area will be length into width. Okay. Length is r d theta, width is dr. So r d theta into dr is the area. So you write dr into r d theta as an area. Okay. So area of the elemental area is dr into r d theta. So you can write it as r dr into d theta. So that's what it is written here, r d theta into dr. Okay. So this is for the smaller area. Okay. Now see this, you have the distance from, consider this is the elemental area. So elemental area from the center of the elemental area to the reference axis. See the whatever the distance, so distance from the elemental area to the reference axis is y. Okay. So y is equal to what? Y is this distance. So radial distance from here to here, it is r, but you are taking the opposite side. No, if you put like this, if you put a small line, that is a line center to the reference axis, as this is the one distance, that you can call it as y. From here to here, if you write another one line here, that is a radial distance r. Okay. But what about this distance? This distance you can call it as x. Okay. So for y distance, what is that y distance? Y distance is nothing but this is a radial polar system. So that's why y is equal to r sine theta. Okay. This will become r sine theta. So x will become r cos theta. Okay. Got it. But we need only the y distance. Why we need y distance is, we know that moment of inertia I is equal to the square area into, sorry, first is the square of the distance. I is equal to square of the distance y square into area. Okay, so this is what the moment of inertia which we have been determined, y square into y square into area. Okay, this is the moment of inertia. So what you have to do it, you have to find out the y. So y is nothing but r sine theta, you have to remember. So y is equal to r sine theta. But what is for the elemental area I? So you, for an elemental area it is small di. Okay, small di is equal to, what is the distance? That is y square. Okay, so y square, the square of the distance you have to take it, don't forget, it is the square of the distance y square. So area of the elemental area, so area of this, you are taking element now, so area will be, you have to take it as dA. Okay, so you can write it as dA. Okay, area of this one elemental area will be dA, don't forget dA. dA will be the area of this smaller element. Okay, so it will be moment of inertia, because of smaller element you should call it as di. So di is equal to y square into dA. So that's what we will further will continue. See here, don't forget this equation, di is equal to y square into dA. Okay, so y is equal to r sine theta. So that's what this is, the y is equal to r sine theta. Okay, di is di with respect to x-axis is y square into di. So that's what we have taken the equation, di is equal to y square into dA. Okay, so that's what here, y square into dA. Okay, now what you do is substitute the value of y. So y is equal to r sine theta. So if you put it, so here it is a square, means you put it square for the whole term. Okay, y is equal to r sine theta, you write it as it is r sine theta, square is there, you put it. Okay, so dA, so what is dA? dA value is r dr into d theta. So you put it r dr into d theta. Okay, you should put it every insert each terms. Okay, so here nothing we have done, r we have removed outside, dr and the theta we kept it another end. Okay, so now, so whatever it is there, you square it on both whatever the terms are there, you square it. So it will become r square into sine square into r into dr into d theta. Okay, so whole term dixx is equal to, so r is there, it will become r square. After squaring it will become r square. After the r into square, it will become r square, another r is there, so it will become r cube. Okay, so this will become sine square, and here dr and theta you have to keep it as it is. Okay, now integrate on both the end. Okay, so integrate it, if you integrate di, you will get I with respect to xx. Okay, now r cube, first there is a double difference, sorry, two terms are there. R, you can two variables is there, that is r and dr, and sine square theta and d theta. So what you have to do is, you have to integrate twice. Okay, so first you integrate each one term. Okay, so here this is the circle, if you take this one as a reference axis, so if you come like this, this is 180, another one circle, it is 360. So variation is from 0 to 360 degree. So limit is from 0 to 360. This is, the 0 is the lower limit and 360 is upper limit. So that's why here variation is 0 to 2 pi. Okay, so that is for the full circle. But if you take from the smaller vehicle, smaller element. Okay, so variation, smaller element, the length is from the center to it is origin. Okay, but if you take for the, that is one is here, the variable is, one is d theta. D theta varies from 0 to, this varies from 0 to 2 pi. Okay, but what about dr? So dr varies from 0 to maximum is r. What is the radial distance? We don't know, you keep it as 0 to r. So variation is from 0 to r. Okay, so whatever the first term you take it 0 to 2 pi, and for the sine theta you differentiate. So what you will get it is sine square, or sine square. How what you have to do is, so use the cos 2 theta. So cos 2 theta is equal to, so cos 2 theta is equal to 1 minus, sorry, uh, so 1 minus 2 sine square theta. Okay, so what you do is 2 sine square theta you send it here, and cos 2 theta you send it here. So you will get it 2 sine square, 2 sine square theta is equal to 1 minus cos theta. Okay, so that's what. So 2 sine theta, 2 sine square theta, it will comes here, it will come 1 2 cos theta, it will come here. Okay, just interchange it, that's all. Okay. So finally 2 you send it to downwards. Okay, just 2 you have to send it downwards to right hand side. Okay, so finally sine square, sine square theta is equal to, we'll get 1 minus cos theta divided by 2. Okay, so finally sine square, in the place of sine square theta you have to write it 1 minus cos theta divided by 2. So that's what it is written here. Sine square theta is equal to 1 minus cos 2 theta divided by 2. So here, sorry, here after shifting here, you have to write it 2 cos theta. It is 2 cos theta now. Okay, here it is 2 cos theta. If you bring it here, if you bring it here in this place, it will become 1 minus the same, it will be 2 cos theta, whatever it is there, it is 2 cos theta only here. Okay. So sine square theta is equal to 1 minus cos 2 theta divided by 2. Okay. So it is 1 minus cos 2 theta divided by 2. Okay, so with respect to, you are integrating with respect to d theta, so you integrate it. Okay, 2, it is a denominator, it is a constant, you bring it outside. So d theta, if you integrate it, you will get theta. So cos 2 theta, whatever it is there, if you integrate it, you cos integration, it will be sine. So this will be sine 2 theta, same as it is. But 2 theta again, if you integrate it, that 2 will come to denominator. Okay, so that's why initially only what you have to do is, this denominator 2 is there now, so this denominator 2 is a constant, so you bring it outside. So it will become half integration 0 to 2 by 1 minus cos 2 theta into d theta. So d theta, if you multiple on the both end, you will get it as d theta minus cos 2 theta into d theta. So this is what you will get it. So sorry, this one. Okay, so this is the one product and this is the another one product. So if you integrate d theta, you will get theta. So cos 2 theta integration is sine 2 theta, but again 2 theta will be there, that you have to integrate it. So finally that 2 you have to bring it to downwards. Okay, whatever inside it is there, you have to differentiate and you have to bring it. Okay, so inside whatever it is there, you have to differentiate. So what is that, you have to get it, you will get a 2 is a constant. So differentiate of theta with respect to d theta is 1. So x into dx, x differentiation with respect to x means dx is 1. So like that, do 2 theta, if you differentiate whatever the things will be there, so the x theta is the variable, so theta if you differentiate, it will become 1, and 2, it is a constant, you have to bring it downwards. Okay, this is how integration you have to do it. Okay. So consider if cos 3x was there with respect to dx, if you are integrating, so what you have to do is, after for the integration, so cos 3x will become sine 3x, you will get it. So yeah, 3x whatever it is there, so inside whatever it is there, you have to differentiate with respect to x. Okay, if you integrate, so 3 will remain constant as it is, but x if you differentiate, you will get 1. So finally integration of cos 3x will be sine 3x divided by 3. Okay, so this is just an example I have given. So to integrate cos 2 theta, okay, cos 2 theta will be sine 2 theta divided by 2. So next, this is the whole term is a constant. Okay, this whole term you have to treat it as a constant. Okay, clear? So next in the whatever the limits are there, so 0 to 2 pi you have to put the limiting value. So theta, if you put it 2 pi, so 2 pi minus sine 2 pi, sine of any pi is 0, so whole term will become 0. Okay, only in the place of theta whatever you put it, so it remains 2 theta as it is. Okay, so I'll repeat once again, whatever the theta here it is there, so in the place of theta if you put 2 pi, totally it will become 4 pi. Sine of any pi, okay, sine of any pi is 0. Okay, sine of any pi is 0. Okay, got it. So that's why this will become 0. Okay, so totally the answer, this whole term will reduces to 2 pi. Okay, next r cube into dr, it will comes to denominator as it is. Now we have to do integration with the 0 to r. This is the double differentiation, sorry, double integration. So integration from 0 to r, so second integration whatever it is there, you have to integrate another ones. Okay, 0 to r, 2 pi it is a constant, r cube into dr, so 2 pi is a constant, now it will come to the outside. So left rest of the things are 2 pi by 2, so half is there, so I have written as it is. Okay, 0 to r, so r cube into dr. Okay, so r cube into dr, if you integrate, what you will get it, 2 pi, this 2 will get cancelled, so you will get pi 0 to r. So r cube if you integrate, what just it is like x to power of n, x to power of n, if you integrate it, what you will get it, x to power of n plus 1, whatever the numerator it is there, you have to bring it to denominator as it is. Same like that, r cube if you integrate, so let me write it as it is, r cube into dr. Okay, so pi I will write it as it is. So r cube if you integrate it, you will get r to power of 4, whatever the power is there, you have to bring it to downwards, right, 4 as it is. So finally answer will be pi r to power of 4 divided by 4. So finally the moment of inertia will be, this is for moment of inertia with respect to xx, reference axis xx. Okay, so it will be pi r to power of 4. Okay, this is for I in the reference with reference to x-axis. For the with respect to y-axis, it will be similar, it will be very similarly, it will be like pi r square to power of 4 only. Either you take it from reference axis xx or yy, so it will remain same, pi r square divided by 4. Okay, so if you put r is equal, d is equal to 2r, sorry, r is equal to d by 2, if you put r is equal to d by 2, so finally in the place of r, you if you write d by 2, so finally you will get it as pi d to power of 4 divided by 64. Okay, this is the formula you have to remember. Pi d to power of 4 divided by 64 is the final answer. This is the moment of inertia for the circular section. For the circular section, whatever the circular section is there, for this circular section, the total moment of inertia for this circular section is pi d to power of 4 divided by 64. So this is the one complete problem, one complete derivation of circular section. Okay, so one small thing is there here, you see here. So finally I got pi d power of 4 is equal to 64, pi d to power of 4 divided by 64 is the final moment of inertia. So we know that radius of the gyration is ixx divided by area. Okay, so what you have to do is, area is pi r square, ixx is you write pi d square divided by 64, whatever it is there you write it, t is equal to 2r you write it. So finally the kxx and ky will become r divided by 2. Okay, so radius of gyration will be r divided by 2 for the circular section. Okay, so if you take for a polar moment of inertia, see here, for the polar moment of, this is an addition information. polar moment of inertia Izz is equal to Ixx plus Iyy. Okay, so Ixx is equal to pi r square to power of 4, pi r to power of 4 divided by 4. Okay, whatever we have taken this if you put d is equal to d is equal to 2r, you will get like this. Okay, pi r square, that's actually before right before finding this, so you will get the Ixx is equal to pi r square, so Iyy is equal to pi r to power of 4, the same formula only. Okay, but in this, if you put dr is equal to d by 2, so then it will be you will get it as pi d square divided pi d to power of 4 divided by 32. Okay. So finally, the polar moment of inertia for the z-axis is equal to, you will get r divided by root 2. Okay. So this is an extra information. This you no need to derive. So till here, pi d squared pi d to power of 4 divided by 64. Till you find it till here and leave it. Okay. This is an extra information. That's all.